Students, this is lecture 9, Network Computational Process. This lecture is a continual lecture for lecture 8. In this lecture, we are going to discuss how to compute project networks. There are two methods. Method 1 is forward pass or earlier times, and method 2 is backward pass, latest time. Why we need to study network computational process? When we draw the project network places or the activities in the project network in the right sequence for computing start and finish times of activities. Activity time estimates are taken from the task times in the work package and added to the network. Performing a few simple computations allow the project manager to complete a process known as the forward and backward process. Completion of forward and backward process will answer the following questions. Hence, that when we are dealing with network computational process, we may have to do both forward pass and backward pass. Okay. Forward pass, earliest time. This process will answer the following questions. How soon the activity can start? Usually it's represented by ES, means that early start. How soon can the activity finish? Early finish, represented by the letters EF. And how soon can the activity or the project be finished? The whole project will be finished, which means the expected time, time A. When dealing with backward pass, latest times, it answers the following 4 questions. Actually, the first three questions. The fourth question can be answered by using both methods. How late can the activity start? Late start. How late can the activity finish? Late finish. Which activities represent the critical path, CP? This is the most important term, as we discussed in lecture 8. This is the longest path in the network, which, when delayed, will delay the whole project. The fourth question is, how long can the activity be delayed, slack or float for each activity? This is also an important term for each activity, means SL. The slack or float activity for the critical path activities is 0, is always 0, which means that we cannot delay this activity whatsoever. We will discuss that later. Forward pass, earliest time. How can we compute it? The forward pass starts with the first project activities and traces each path a chain of sequences activities through the network to the last project activities. As you trace along the path, you add the activity times. The whole process can be explained on the diagram, but first let's read the points before showing it to you on the diagram. The longest path denotes the project completion time for the plan and is called the critical path. The forward path requires that you remember just 3 things when you're computing. Early activity times. You add activity times along each path in the network, which can be calculated or computed by early start plus the duration of that activity. And you will find the early finish for this activity. You can carry the early finish, EF, to the next activity where it becomes its early start, ES, unless the next succeeding activity is a merge activity. In this case, you select the largest early finish number. This is so important. And we will look it on the diagram as well. Of all its immediate or predecessor activities. Let's take the example for the forward pass. This is a project that has how many activities? 1, 2, 3, 4, 5, 6, 7, 8. 8 activities. We have how many merge activities? we have one merge activity here, letter E, which is why it's merge activity, because there are two arrows flowing to it. We have F and merge activity. It has the three arrows flowing to it. We have also H and the merge activity. We have two arrows flowing to it. Okay, remember the following sentence. When there is the next succeeding activity, the merge activity, which early start we should use? In this case, you select the largest early finish for the early start of the merge activity. Let's see in the example. Look, we have here activity F has an early start of 20. Why? Because let us see what are the merge activities that made F, or they flow to F. We have activity B, its early finish is 20. Activity C, its early finish is 15. Activity D, its early finish is 10. What is the largest number among those early finishes? We have 10, 15, 20. Then we should select 20 because it's the largest early finish number of all its immediate predecessor activities. Okay, this is an example. Before that, let's discuss the diagram legend for the activity of the network. In this legend, there are 5 items. Actually, there are 6, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 symbols or component of the activity. The one in the middle of this is the ID, the unique ID. It does not affect the computation. The description is just like the name of the activity. So the values we are concerned with is ES, which is the early start, EF, which is the early finish, SL, which is the slack time or float, LS, because the latest, we will discuss it later when we explain backward pass. And we have duration. Duration can be computed from EF minus ES. And we have LF, which is latest finish, latest start, latest finish. Okay, for the forward pass, when there is the start activity, it's always start with value 0 because there are no earlier activities before A. So it will start by what? By 0. This activity, say, takes 5 days. So its duration is 5. So to find out what's the early finish, we will add duration to the early start. 0 plus 5, it will be 5. This is the early finish. Next, as you can see, each activity it has on its duration. This is already written by the planning team because it should have its duration time. It's pre-designed for this. Okay. After A is burst activity. Why it's burst activity? Because there are 3 arrows or more than 1 arrow flowing from it. So okay. Let's see. Because the early finish of A is 5, all early starts of the following parallel activities should be 5. This means that whenever an arrows come from an activity to another activity, its early finish will be copied to its early start. 5, 5. 5 here is also 5. Here is also 5. Okay. Let's take B for example. B has a duration of 15 days. So we will add 15 to 5. The early finish is 20. This means B will be finished after 20 days from the start of the project. Good. Let's go to this jump to C. C has a duration of 10. 10 plus 5, the early finish will be 15, which means that C can be finished in 15 days. Okay, let's jump to D. 5 plus 5 is 10 as well, which means that D can be finished after 10 days from the start of the project. But look at here, we have 3 parallel activities, and they all go to activity F. Also B and C, they go to activity E. Okay. So what is the value of early finish or early start of F? As the rule says here, if there is a merge activity, in this case select the largest early finish, EF, of all precedents. So since F cannot be started until all the 3 activities has to be finished, then we will take the largest number, 20. 20 will be the largest number. Okay. Then the early start of F will be 20. The duration of F is 10 days, so its early finish will be 30. Okay, before we jump to G, we have to finish E. E, it depends on B and C. They both have 15, 20, so we will select the largest. The largest is 20, and E has 15 days duration. So 15 plus 20, 15 plus 20, it will be 35. Okay, why we draw E after F? Because as you can see, the early finish of F is less than the early finish of E, so we put E after block F. Okay, now let's go to G. G has a duration of 170. Look, when we don't have merge activities, we just need to copy the early finish to early start. You don't have to do anything else. Okay, let's sum up 30 with the 170, it's 200. And we have now activity H, which is a merge activity as well. And we have 2 values, 2 early finish values, 35 and 20, 200. As the rule says, you have to select the largest early finish, which is here, is it 200? So H will start 200. It means that H will start after 200 days from the beginning of the project. Before that, it can be done. H has 35 days of duration, so the total time of early finish for H is 235 days. This time is the time of the whole project. Okay, there's one question. Can you identify where is the critical path? We have many paths here. We can say the path of the project is A, B, F, G, H. And there's another path, A, C, F, G, H, or A, C, E, H. But there is one condition. It says that the longest path of the project network is the critical path, which means we have to go with the largest early finishes. So A has early finish with 5. The next step, we will look for the largest early finish, which is B. So the critical path will be A, B. Then B, it jumps to 2 activities, E and F. So where should we go? Okay, the longest path here, the largest early finish here is 35. So we can go to 35. So the critical path will be A, B, E, then H, which is this is the only activity left. So one can say that, oh, okay, you missed F. You may say that there is another critical path, which is A, B, F, G, H. Is this true? No. Why? Because we say that the critical path, when you delay a project, it will delay the whole project, which means that sorry. We have now two candidate paths for critical path: A, B, E, H. A, B, F, G, H. Which is the critical path? The critical path is, as its definition, it says the longest path. Both of them that are longest paths. But you have to see that to finish E, you just need 35 days. But to finish G, you have to do 200 days. So this will be cancelled. Like A, B, E, H will be cancelled. It's not considered as a critical path. So the only critical path here, A, B, F, G, H. We will discuss later how to make sure that this critical path is the actual critical path when we study the backward path, the latest time. The backward path starts with the last project activities on the network. It starts from the end. You trace backward on each path, subtracting activity times to find the latest start and finish times, the latest finish for each activity. Before the backward path can be computed, the late finish for the last project activities must be selected. The backward path is similar to the forward path. You need to remember three things. You subtract the activity duration from the latest finish to find out the latest start. Okay. You carry the ls to the next preceding activity to establish lf, just the same as the forward path. Unless the next preceding activity is a burst activity, as the opposite of merge activity. In this case, you select the smallest ls of all SMPs. Not the largest, it's smallest. Let's see the example here. We have the same project, but instead of doing it forward pass, we will start from H. Okay, we have the duration of H 35. Okay, and it has total number of days duration 235 because this is founded by this forward pass actually. So the number 235, we can borrow it from this 235 because the last or the end activity, it should have its early start is early finish is equal to the latest finish, ls. So we have the project duration 35. We subtract 235 from 35, we'll get 200. And we have here two activities. Okay, so the 200 will be copied to the latest finish, the same. Subtract both, have the same here, and 185 here, and 185 here. Okay. One can say why we didn't copy 185 here and here. This is actually what the last step tells you. You have to select the smallest ls. So before we proceed to B, C, D from E or B, C from E, we have to finish G and F. G has 30. So F latest finish will be 30, subtract by 10, it's 20. So we have two activities here that they share the both activity stock. So 20 and 185, which is the smallest? The 20, of course, of F. So we have to choose F as the 20 as latest finish for the both E, B, and C. For D, it's all obvious, it's 20 because it has only one activity following to it. Okay, now we have 20, 20, 20. Subtracting by duration, we have 5, 10, 15. Well, we have three numbers here. Which one to choose is the least number, which is 5. We have 5 here, 5, and if we finish with number 0, it means that our computational process is true, is right, because it has the latest Start should be 0. Okay, now we have to determine the slack or float. This is a very important term in project management, a project management or network computational process. When the forward and backward passes have been computed, it is possible to determine which activities can be delayed by computing slack or float. Total slack, TL, tells us the amount of time an activity can be delayed and not delay the project. This is a little bit ambiguous, it's not clear, but we will clarify it with the diagram. Stated differently, total slack is the amount of time an activity can exceed its early finish date without affecting the project end date or an imposed completion date. The activities that are not on the critical path, they have total slacks because we can delay them a little bit without affecting the whole project. Total slack or float for an activity is simply the difference between LS and ES, which is the latest start, earliest start, LS minus ES is L, or LF minus LF minus EF, which is latest finish with early finish. For example, in this term, we copied all the forward and backward numbers, and we will find the number, the slack time. As we can see that if we subtract the LES, early start, with latest start, LES, early start with latest start, 0 by subtracted by 0, it will be 0. For activity B, the same thing. But you can compute the SL from EF minus an LF. 5 subtracted by 5 will be 0. Okay? One say, okay, we say that we will subtract LF by EF. If you subtracted it in opposite direction, you will have a negative value. Just remove the negative value, you will have the SL as well. Just in this one, activity B, because it's in a critical path, it should be 0. 20 minus 20, 0. 5 minus 5, 0. For activity C, it has little bit slack here. Why is there is a slack here? Because if we subtract 10 by 5, it will be 5. Subtract 20 by 15, it will be 5. Okay? This means that if we delay or if we delay the activity C by 5 days, there should be no problem for the whole project because it has a slack time of 5 days. Okay? But so the number one project or number one activity here that has highest priority is B. Why? Because it has a slack 0. We don't have any time to lose while doing B. This is important. What's the slack time for D? 5, or 15 minus 5 is 10. 20 minus 10 is 10. So we have 10 days slack here. For F, we don't have any slack time. For E, we have 165 slack. Look at this. This is another condition why we didn't choose A, B, E, H as critical path, because it has a slack. Activities that doesn't have slack, look, A, B, F, G, H, they all have slack of 0, which means that this is the only critical path. We don't want to mess with these activities. We don't want to delay these activities, because if we delay any one of these activities, even 1 day, it will delay the whole project by 1 day. Okay?